Hello, welcome to a video on page 3 of the section 6.2 notes. So here we're going to talk about anti-differentiation using substitution. And before I do that, it's very good to make note of a term called a differential. So the dx part of this integral right here is called a differential. And we're going to be looking at that a little more closely when we do anti-differentiation using substitution. So let's start with example 3. So here we're asked to find the indefinite integral of 14x times e7x squared times dx using substitution u equals 7x squared. So again, we're going to let u equal 7x squared. So that means that du over dx, the derivative of both sides with respect to x, is going to be du dx equals 14x. And if I do a little bit of nifty algebra, I can multiply both sides by dx and get that. So that means that my integral now can be rearranged in this manner. And then I could substitute, where this part is the same thing as du, and of course this part is the same thing as u. So therefore, I have e to the u power times du, and that would be e to the u plus c. So now we turn into an easier type of expression to integrate or anti-derive, or anti-differentiate using proper, I guess, verbiage there. And then I could bring 7x squared back in, and voila, I have the answer. That's what y equals. And I know y is going to equal that, because if I were to take the derivative of that, it would be e7x squared times 14x plus 0, because the derivative constant is 0, or 14x e7x squared. So I know this works. So this is kind of a formal technique of finding the antiderivative of some things that might look a bit nasty, or when you have seems like you got two functions being multiplied together. So, we don't use product rule, for antiderivatives or anything like that, but this gives us a way of finding the indefinite integrals in a more formal and systematic way. So let's try this again for example 4. So u equals 1 minus 2x to the 5th power. So it means that du over dx will be negative 10x4. Or du equals negative 10x4 times dx. So you can see what I'm trying to do is I'm trying to separate the differentials like I did in the previous example. This will allow for substitution to kind of take place more seamlessly. And I'm also going to get a little bit creative here and divide both sides by negative 10. You'll see why I'm doing this in just a sec. So now let's focus on this integral here. I could rearrange it like this. And we could do this because we're in a square root is raised to the 1/2 power, x4 dx. I'm kind of putting those closer together. They're all being multiplied, right? And the 7 I could push off to the left. That's because we talked about when you have a constant being multiplied to a function, you're allowed to put the constant to the left of the integral symbol. And it's still the same thing. So now I substitute. 7 integral u to the 1/2 power times du over negative 10. That's because this portion right here, right, that we got from over here, is du over negative 10. And of course, this portion right here is just u. So now when I do my antiderivative, 7 times u to the 3/2 power, divide by 3/2, and actually I can make that 7 over negative 10, by the way, plus c. So I have negative 7/10 times 2/3 times u to the 3/2 power plus c. Or I can reduce this to get negative 7/15 parentheses 1 minus 2x to the 5th power the whole thing raised to 3/2 plus c. If you were to take the derivative of this, you would actually wind up getting back to the expression that you see over here. You could work it out if you don't believe me, but trust me, it will work. And then lastly, example 5. So typically you want to let u equal the kind of the more nasty thing, or in this case, the expression has like the largest exponent, because we're going to be taking the derivative of it, which will obviously cause the exponents to go down by 1, and probably substitute for that expression over there that I just circled in red. So du over dy now, remember we've got y here, is 6y5 plus, ooh, that's squared, 10y. And if I get a little bit creative, multiply both sides by dy and factor out a 2, I'm not going to factor out a y because I want to substitute for 3y5 plus 5y. So I'm deliberately rewriting this so I can seamlessly substitute afterwards. So now my integral is going to be an integral of 10 times u to the 7th power times du over 2. Or it will be 5 integral u to the 7th power times du. Do the antiderivative, you get u8 over 8 plus c will be 5 y6 plus 5y squared minus 3 raised to the 8th power all over 8 plus c. So that covers page 3 of the notes. We'll discuss this again in class, and then when we start class again, we'll be able to kind of hit the ground running doing the last 7 examples, examples 6 through 12, pages 4 through 6 of the notes. All right, have a great day. Goodbye.